Hello and welcome back to the channel. So in this new tutorial series, I will let you know guys how I have set up this quadruped dog motion matching character. So we will learn how we can set up this walk, trot and run behavior. And also I will let you know guys how I have set up this trajectory generation so that when we press opposite input our character take a circular turn instead of going back in a straight line, so that we have a natural movement for our quadruped. So let's get started guys. So this is the default third person project which I already have created. You can see our mannequin is running around, and I have already imported this animation pack from marketplace, our dog character and all the animation, and I have also enabled the desired plugins for which we required for motion matching. So we need animation locomotion library, we need chooser, we need pose trajectory, motion warping, pose trajectory, and pose search. So these plugins which we need in order to start working with motion matching. So I have already set these up for this project. So first thing first, I have my folder dog motion matching assets. So this is the default character blueprint. I have already named it to the character blueprint underscore dog. So we will replace our mannequin with this dog character, and now when we play you can see our dog character is running around in the level. So first thing is we will set up our animation blueprint. I will go to the animation blueprint, select my skeleton ABP underscore dog, open it up. So we need first we need the motion trajectory in order for motion matching to work. So I will go to the event graph. So I will search for event initialize blueprint initialize animation. So I will get a reference to my character, target pawn owner, class plus CBP dog. So this will be our character. I'm gonna search for character movement component, promote to variable. So this will be our character movement component. I'm gonna set the category for reference, put it over here. All right. So in our update animation function, we check if our character is valid. Is character valid? So when our character is valid, we will then start updating our functions. Okay. If I now print string and check if it is working fine, we will set our animation blueprint over here, ABP dog. So here we can see the print string true. Print string is true. Now we need to set up our trajectory function. So I'm gonna add a new function, update trajectory. The category will be trajectory, and I'm gonna search for generate for search generate trajectory for character. All right. So this will be our thread save function because we will call it from our blueprint thread save function. We need to create parameters. So anim instance. So make sure you will put here the get owning component and get the anim instance, current anim instance over here. And for trajectory data, I will promote to a variable, call it trajectory data. Delta time, we already have this in property access, delta seconds. So here we pass by reference our trajectory. I'm gonna promote a variable and call it trajectory simply. And for this, I'm gonna call this desired last update. So these are the required variables. Just a moment. Update trajectory. So we need to set up these intervals at sampling interval set to -1, history count 30, prediction to -1, and prediction count. So I already have discussed and explained these all the parameters in my motion matching breakdown tutorial series part 1. So I will not go in details. So I just set these up to the default value. So in order, if you want to look into what are these values used for, you can go and watch my other tutorial, breakdown motion matching series. So now we are passing by reference this trajectory. We will set it over here. So this is our trajectory. Now we need to call this function. So I'm gonna override our blueprint thread safe update animation. And first we need to check if our player is valid. Is character valid? I will move these variables to their category trajectory. So if our character is valid, we will call this function update trajectory. All right. Now we need, in order to debug our trajectory, we need to place the pose history node inside our animation graph. So this will be your last node to the animation graph for motion matching. So I will add a pose history node, and for trajectory, we already have created a variable. I will set it over here and set it initial as with reference pose. All right. Now when I hit play, you can see. So in order to debug your trajectory, you need to enable the CVAR. So for this, I'm gonna search for trajectory. Here you will see a.anim node pose history draw debug trajectory. So if I set it to 0, if I set it to 0, you will see we don't have any trajectory visible. So now I need to see the trajectory. So here we can see we have the trajectory in appearing. So our animation blueprint is set up. Now we need to set up our trajectory so that first of all we need to set up few parameters for our trajectory data. So I am gonna set these to 0 and 0. So now you will see when I rotate my mouse or my controller, you will see the trajectory is smooth. It is not flickering around as compared to before. We have this like 10 or 70 over here. So if I set that way, you will see when I just rotate my mouse a little bit, our trajectory is snapping around. So in order to remove this, I will set these to 0, 0. So we have a smooth trajectory which follows the controller movement. So we need a trajectory so that our character doesn't immediately go to the backward side, backward directions. currently you will see when I press opposite key, the trajectory is linear to the opposite side, like 180. But instead what we want, because we don't have a huge coverage of animations, like the dog can start with 180 right, 180 left, 90 left, 90 right. So we only have few animations like simple walk, trot, and run, like in a straight direction. So we don't have huge coverage of animation. So in order to work with the motion matching with this way, we need to generate our trajectory in such a way that we can mitigate these errors. So what we require is, when we press the opposite key, we will take a circular turn. Like we don't immediately go to the desired direction as we are currently doing. When I press A, like left key, you will see the trajectory immediately goes towards left, right. So but instead we want a circular turn, so that while playing a simple straight animation, our dog perform a circular turn to the desired direction. So in order to make this happen, we will need to fix our trajectory generation. So the easiest solution for this would be to change our input. Currently you will see we have a input axis. We are providing the input, add movement input directly in controller direction. But instead what we want here is, I will remove this function from here completely, the input movement. So now when I press WASD, my character is not moving. So first thing first, we need let's give me a second. So first I will create a new event tick. I will add an event tick over here. Okay. So I will create a new function, calculate movement. Calculate movement input. Calculate movement input. I am gonna call this function at my event tick. Sorry, I need to create a function, not a new event graph. Calculate movement input. And I'm going to call this function at my event tick. So inside our calculate movement function, first thing is I'm gonna grab my get controller rotation, and I'm gonna promote it to a variable, current controller rotation. This is our current controller rotation. We only want yaw, but instead of pitch and roll, so I will set this rotation like so. The roll and pitch will be 0. So this is our current controller rotation, and we already have our input axis underscore move. So these are our x and y input directions, like WASD input axis, x and y. So this I will add a new variable, current input vector. So this will be our current input vector. I will set it over here, set the variable type to vector, current input vector. And for this I'm gonna make vector and set the x and y over here. So in order to debug, let's just grab our input vector, make rotation from x, and draw debug coordinate system. Get actor location, get actor location and debug our rotation. So now when I hit play, you will see our input vector. So currently when I press W, the input vector is towards right side, but when I press D, our input vector is left side. So this means we need to switch our X and Y. So I'm gonna switch it to over here. So now when I press WASD, you will see our input vector is in a right direction. So here I'm pressing W and D, and you will see it points towards the 45 right, and when I press WA, it points towards the 45 left. So this is our input vector. All right, next thing is input vector is done. We will grab our input vector, make rotation from X, and we will promote it to a variable. This will be our current input rotation. So we have our current controller rotation, current input rotation, and we will check if our input vector is valid. Like we will check the length, vector length. If it is greater than 0, which means our input is valid, only then we will start calculating our input. So we need two new variables: target input direction, target input rotation, and target controller rotation. Target controller rotation. So these variables will be our rotator. The type will be rotator. So we have our current input rotation, current controller rotation, current input rotation, and we will set our target input rotation and target controller rotation. So this is our target input rotation. First we will set this up. We will use interp to constant. And target will be our current input rotation. Delta time get word delta seconds. The interp speed. So I'm gonna promote this to a variable. We will switch this interp speed for our walking, trot, and so that we have different rotation rates for different states. So first of all, I'm gonna promote it to a variable. Movement interp speed. I'm gonna call it movement interp speed. So we will start with walking first. I will set this interp speed to 120 for now. All right. Just give me a second. I will double check my notes. Yeah, 120. So our input rotation is done. Now when I try to debug this input rotation, target input rotation, you will see when I press WASD, the input rotation is instead of snapping in the input direction, we are interpolating towards the desired rotation with 120 rotation rate. So now we need to use this information and move our character in this direction. So I'm gonna create a new function. What I will do here is create a new function, perform movement. So inside our perform movement, we need a direction for X and Y. X and Y. So now in our perform movement input function, I'm gonna add a new function, add movement input. And for the world direction, we will grab our target controller rotation. Instead of getting our current controller rotation, we need to set up the target controller rotation. So I will set up the target controller rotation first as well. This will be the same as our input rotation. R interp, like so. And current controller rotation, delta time will be the same, and movement is also the same. And after that, we will call our function perform movement. And X and Y will be our input rotation, X and Y. Target input rotation, split X and Y. Sorry. Get forward vector, target input rotation, forward vector, split, and put the X and Y over here. So what we have done here is we have our current input rotation, current controller rotation, current input rotation, and we are setting up our target input rotation with some interpolation. Target input rotation is the same as current input rotation but with an interpolation. Similarly, target controller rotation is same as current controller rotation but with some interpolation happening. And after that, we are performing our movement. So inside our movement function, we have our target controller rotation, which we have interpolated. And I'm gonna grab the get forward vector. Get forward vector, this will be our world direction. And for the X, I'm gonna set it over here. This will be our X direction. Similarly, for our, because this is a forward and backward movement, we need left right movement as well. So I'm going to add a new add movement input, grab my target controller rotation and get the right vector. Get right vector. This will be our left and right movement. And for left and right movement, we will use our Y value. Y input value. For forward and backward, we are using X, and for left and right, we are using the Y value. And now everything is done. Now let's hit play and see what is happening. Here you can see. So when our character is moving, when I press opposite key, opposite input, our character, instead of going in a straight line, we are making a circular turn. So currently this circular turn is a really large circular turn. So we will fix it using our animation speed. What is the speed of our movement, and then we will fix it. So the important thing is our trajectory is almost done. So now let's fix this circular turn. So first thing is I'm gonna, let's just grab for testing. I'm gonna grab my animation walk, local walk loop. This is our walk. So for finding our speed, what is the speed of walking, we have our animation modifier, motion extract modifier. So I'm gonna grab my rig root. I will So I'm gonna try to find the speed of the animation. So we will search for translation speed in X and Y. Translation speed in XY, and use a separate curve. Move data underscore speed. So if I apply modifier, you will see our walking speed is 77. So 77 is our walking speed. So we can set up our current movement speed to, let's say, max walk speed. If I search here, max walk speed, this is our max walk speed, currently set up to 500, which is way too much. So this will be most likely our running speed, but first we'll set up our walk, trot, and then run. So I will set up the max walk speed to 80, let's say, for now. So now our speed is 80, and you can now immediately see that our trajectory is also changes, trajectory length, and also our circular turn is also narrowed down, because it's based on our speed. So in this way, so I think that's it for this part. In this part, what we have done here, we have set up our project animation blueprint. We have set up our most important thing, which is our post trajectory. So our post trajectory generation is done. In our next video, we will set up our motion matching for walking, and then we will proceed further. So I will see you in the next one.